The atmosphere and the ocean form a coupled system, with changes to one affecting the other. There are three main properties that are exchanged between the two systems. The first is heat, which is directly felt by the atmosphere mainly through the sea surface temperature. Salinity, or fresh water. This can be exchanged through precipitation and evaporation, with evaporation causing the ocean to lose fresh water and the atmosphere to absorb it, and evaporation causing the ocean to increase in salinity as it loses fresh water. The third is momentum, which is mainly felt through the ocean due to wind forcing from the atmosphere. This system is complex for a number of reasons. One is that local changes to one of the properties might not necessarily be felt locally. For example, if there's precipitation in one region of the ocean, rather than the ocean evaporating that precipitation back into the atmosphere at the same point, ocean currents could move that fresh water elsewhere in the ocean before it's evaporated. Another factor adding complexity is the notion of feedback loops. A simple form of feedback loop is if you imagine an object is heated up, or part of the sea surface is heated up, then the increased temperature of that object means that it will radiate energy more quickly away from itself, cooling it down in turn. So an increase in temperature then results in a mechanism which decreases the temperature back to its original point. However, these feedback loops can be much more complex. One example of a more complex feedback loop is if we imagine there's a cold region of the ocean next to a warmer region of the ocean, or perhaps a warm body of land. As the air passes from a colder region of the ocean to a warmer region of the ocean, that air can then convect upwards as it's warmer than its surroundings. That warm parcel of air that rises up through the layers of the atmosphere then needs to be replaced by mass at the bottom of the atmosphere. This results in lateral winds. These winds are then felt in turn by the ocean, causing a drag at the surface. This wind forcing of the ocean can then result in what's called Ekman pumping, a mechanism that can bring colder water in one of the deeper layers of the ocean upwards or downwards. In turn, this Ekman pumping can change the sea surface temperature as colder waters are brought closer to the surface, which in turn changes the sea surface temperature. So we see this is another feedback mechanism where sea surface temperature affects sea surface temperature through wind and the atmosphere. Over longer timescales, we expect the three properties, momentum, heat, and salt, to roughly balance each other between the ocean and the atmosphere. However, small timescale perturbations are possible if positive feedback loops amplify themselves, resulting in deviations from a mean state. This is what results in climate variability between the ocean and the atmosphere. The most famous example of long-distance climate variability is the El Nino Southern Oscillation, where changes in temperature in Australia are coupled with changes in temperature thousands of kilometers away in South America.